Welcome to today's Explainer. Get ready because today we are strapping in for the ultimate cosmic detective mystery. This is one that literally challenges everything we thought we knew about reality. We're going to explore the darkest, most massive secrets of the cosmos. It's a journey that takes us right to the very edge of human understanding. And honestly, by the end of this, you're going to look up at the night sky in a completely different way. So let's just dive right in. You know what's really wild about the universe? It's what it says about you, me, and everything we have ever known. Think about it. Matter as we know it, atoms, stars, galaxies, planets, trees, rocks, even us, all of that accounts for less than 5% of the known universe. Less than 5%. About 25% is made up of something called dark matter, and a massive 70% is dark energy. That means 95% of the entire universe is completely invisible to us. It's kind of like sitting in a giant room where you can only see a tiny piece of the furniture, and the entire rest of the room is just hidden in total darkness. It's a pretty humbling reality, right? Everything we experience on a daily basis is really just a tiny, tiny fraction of reality. But, as with any good mystery, it gets deeper. The truth is, we have absolutely no clue what dark matter and dark energy actually are. We don't know how they work, we don't know what they look like, and their fundamental mechanics are a total blank to us. But here's the catch. Thanks to the immense power of observation and mathematics, we are absolutely certain they exist. So, let's look at suspect 1, dark matter, the cosmic glue. So why do we call it cosmic glue? Well, when scientists started calculating why the universe is structured the way it is, a massive problem popped up. The gravity from all the visible matter we can actually see, it just isn't strong enough to form galaxies. Without some kind of extra invisible stuff holding everything together, stars would just scatter all over the place. So we know this invisible cosmic glue is out there, holding it all together. But right now, we actually have way more ideas about what dark matter is not than what it actually is. Let's eliminate some suspects. First, it's not just clouds of normal matter without stars, because if it were, it would emit particles we could easily detect. It's also not antimatter. When antimatter reacts with normal matter, it produces these highly unique gamma rays, and we definitely aren't seeing those everywhere. And finally, dark matter is not made up of black holes. Black holes are super compact, and they violently affect their immediate surroundings. Dark matter, on the other hand, seems to be incredibly diffuse, just sort of scattered all over the place. So where does that leave us? Basically, with 3 things we know for absolutely sure. Number 1, something is out there. Number 2, it interacts with gravity. In fact, we can actually kind of see it because places with a huge concentration of dark matter will physically bend the light passing nearby. And number 3, there is a lot of it. So what's the leading theory right now? Well, dark matter is probably made up of some complicated exotic particle that just doesn't interact with light or matter in any way we'd expect. But for now, we just don't know. Which brings us to suspect 2, dark energy, the invisible force. Now, to even begin to understand this force, we need to travel back to 1929. This was when the astronomer Edward Hubble made a truly monumental observation. He was examining the light emitted by distant galaxies, and he was specifically looking at how the wavelengths of that light behaved as they traveled across the vast expanse of space. What Hubble noticed was a phenomenon we call redshift. Basically, as light travels across the universe, its wavelengths stretch out towards the red end of the electromagnetic spectrum. You can think of it kind of like a cosmic game of stretching a rubber band. Hubble realized that this stretching happens for one mind-blowing reason. The universe itself is expanding. That redshift happens because the actual space the light is traveling through is physically stretching out. When Hubble compared different galaxies, he found that fainter, more distant galaxies showed a massive degree of redshift, while closer galaxies showed way less. But here's where it gets wild. More recent discoveries have added a terrifying twist to his findings. See, before this, scientists assumed that the pull of gravity would eventually cause the expansion of the universe to slow down or maybe even snap back and collapse in on itself. But instead, we discover that the expansion of the universe is actually accelerating. It's literally getting faster and faster. Now, to really wrap our heads around this acceleration, we have to understand something fundamental about space. Space doesn't change its properties as it expands, there's just more of it. New space is constantly being created everywhere. Now, galaxies are these tightly bound clusters of stuff held together by gravity, right? So we don't feel our own bodies or our solar system expanding in our daily lives. But out there, in the vast empty voids between galaxies, wherever there is empty space in the universe, more space is forming every single second. So this dark energy seems to be some kind of energy that's intrinsic to empty space itself. It's an energy stronger than anything else we know. And the crazy part is, it keeps getting stronger as time passes. Just really think about that for a second. Empty space has more energy than everything else in the universe combined. But what exactly is it? Well, we've got a few theories. One idea is that dark energy isn't really a thing, but just a property of space. Empty space isn't actually nothing. It has its own energy, generating more space to fill the gaps, which leads to a faster expanding universe. Okay, how about another angle? Another idea is empty space is actually full of temporary virtual particles. These particles spontaneously and continually form from absolutely nothing, and then disappear back into nothing again. And that fluctuating energy, that's dark energy. Or, maybe it's something else entirely. Maybe it's an unknown kind of dynamic energy fluid or field that permeates the whole universe, but it just has the exact opposite effect of normal matter and energy. Now, what's really fascinating about that first theory, the property of space idea, is that it's incredibly close to a concept Albert Einstein came up with way back in 1917. He called it a cosmological constant, basically a force that counteracted the pull of gravity. The only problem, when modern scientists actually tried to calculate the amount of this energy, the result was so wrong and so incredibly weird that it just added to the confusion. If this dynamic fluid or property really does exist, we still have absolutely no idea how, where, or even if we could truly detect it. All of this brings us to frontier science, the great unknown. You see, our theories right now are really just that, theories. But honestly, that's exactly what makes this so immensely exciting. To perfectly ground us here, there is this brilliant thought from our source material. We are still very much apes with smartphones on a tiny, fragile island in space, looking into the sky wondering how our universe works. There's just so much left to learn out there, and frankly, that is awesome. We've built this incredible framework of reality, but we've really only mapped out 5% of the room. So I'm going to leave you with this to ponder. What will we discover next about the 95% of reality that we can't even see? When that light switch finally flips on, how is it going to change our understanding of, well, everything? Thank you so much for joining me on this explainer. Keep looking up, and I'll catch you on the next deep dive.